So this test is what I nickname the sludge test, but it really ought to be called a precipitate test. And I use it to test for metal ions, particularly transition metal ions. And I've got 3 solutions here that are the ones you need to know about for your GCSE. So I've got with the blue one on the end. You shouldn't be surprised to see that that contains copper, so it's a copper solution. This one, this yellowy colour, has got iron with a 3+ charge on it, so it's iron 3 chloride in this one, but it's iron 3 that's important, and that's what's giving it that characteristic of a strong yellow colour to it. This solution has also got iron in it, but this has got iron with a 2+ charge on it, so Fe2+. And this has got a very pale greenish colour to it. I don't know if you can see it against the background, but it's very faint. It almost just looks like pure water. Now, what we're going to do is to add a small portion of that to a test tube, and then I'm going to add some sodium hydroxide solution. Now, the theory is that the hydroxide ions in the sodium hydroxide will combine with the metal ions in these solutions to create a metal hydroxide. Now, the metal hydroxides are insoluble, so we'll see them as precipitates, and they should have very characteristic colours to them. So this one, iron 2, will form iron 2 hydroxide. So that will be Fe, and then in brackets, OH with a little 2 outside it, so iron 2 hydroxide. This one should form iron 3 hydroxide, so that will be Fe, and then in brackets the OH, and this time a little 3 outside it. And the final one should form copper hydroxide, so Cu, OH in brackets again with a little 2. Okay, so we should see different characteristic colours for these 3 different solutions, and those colours of those precipitates are confirmation that I've got the metal ion that I think I've got. And let's just transfer those to the test tubes first of all. That's the copper. This is the iron 3. And in the final tube, the iron 2. Okay, let's try adding the sodium hydroxide to them. You can see it's starting to make a precipitate in there. It's going a bit sludgy looking, and I've got a really distinctive light or bright blue precipitate in there. It looks quite chunky and thick. Okay. That's proof that I definitely had Cu2+ ions in my original solution. So for the next one, this is the iron 3, I'm going to try adding some sodium hydroxide to that. And you can see that's made a sort of sludgy looking precipitate in the bottom. It's got a real orangey brown colour to it. Okay? Now that chemically is identical to rust. So sometimes we say it's got a rusty colour, and that's quite an accurate thing to say because it is rust. But I think the exam board likes you to describe that as brown. Okay, so this is our iron 3 hydroxide precipitate, and that characteristic colour, I'm going to show you against there, that characteristic colour is proof that I definitely had iron 3 present in my original solution. I'm going to try the final one now. This was the iron 2 salt, so this was the very pale greeny coloured solution. I don't know if you can see it against the white at the end of that test tube right there. But let's try adding some sodium hydroxide to that one. And that one is giving us a sort of when it works really well, gives us a kind of a mossy green coloured precipitate in there. Got a slightly sagey colour to it, I think, sagey green. But anyway, that's a characteristic result for a solution that's got iron 2+ in it. You can see it's got this greeny colour to it. Now, if we were to leave it there for a little while, you might start to see that it gets a kind of yellowy orange tinge developing from the top of it. And that's because slowly over time, the Fe2+ is oxidised to Fe3+. And of course, the Fe3+ is that colour. So we'll slowly see the green colour morph into that gingery brown colour. So we really need to be quite swift when we do these experiments to make sure that we're seeing the initial colour, not something that we've left for 10 minutes and then come back to.